So, hello everyone, welcome to our first ever Devbase event. We've got a really great talk from Josh tonight on the slide of CICD and GitOps in Google's Kubernetes engine. Just like to say, during Josh's talk, if you've got any questions for him, you just add them into the chat on Zoom, then we can go through those after the actual talk itself. But first, I'd like to just, there we go. Just do a brief introduction to kind of who we are and why we wanted to set up Devbase initially. So pass over to Lauren to do a quick talk about herself.
Hi everyone. So yeah, as Chris said, I'm Lauren. I actually have had quite an interesting career path so far. So I actually studied maths at university, followed on with a data science master's, where I then joined the Lab Bible group and worked 2 years as a data scientist. I then joined Peak, and the first year at Peak was as a data scientist before I then transitioned into DevOps. I've actually been doing DevOps now for about a year, just coming up to a year and a half. And so, yeah, it's been quite interesting seeing the best of both worlds, in my opinion. And I guess that's everything from me right now. So I'll pass you over to Chris.
Yeah. So I've been a software engineer and at Peak for about a year and a half. So I'm in the DevOps team as well. I initially did chemical engineering at uni, or struggled through chemical engineering at uni, and then went into project management in manufacturing sector, and eventually got sick of that and wanted to change, try and do some kind of cool stuff. So I decided I wanted to work into tech. So I actually enrolled on a coding bootcamp in Manchester, a place called North Coders. So they just kind of give you a brief, basically give you the basic level skills in JavaScript for you to get that first kind of junior development role, which is what I did at Peak. And I've kind of spent the rest of my time split between full stack development and some DevOps work. So why did we want to set up Devbase? Because I'm sure a lot of you are already aware, there's already a great number of great events in Manchester for tech. So why did we feel like we needed another one to all those? And part of the answer to that is with this quote. So this is from a man called Bill Campbell, who was a coach at college level in American football, and then eventually went into business and ended up as a VP of marketing at Apple, and then on the board at Apple and CEO of Intuit. But one of the things he's kind of most well known for, I think, apart from his accolades in business, is as a coach and a mentor. So he was actually the mentor to, or the coach to, Steve Jobs, Jeff Bezos, Eric Schmidt, Larry Page, loads of people and leaders in Silicon Valley. And this is from a book about him called $1 Trillion Coach. And it's part of a big speech that he has called It's the People. But this small section here is, I feel, what we want to accomplish with Devbase. And it's that great people flourish in an environment that liberates and amplifies that energy. This environment is created through support, respect, and trust. And it's kind of what we want to set up with Devbase. Really, we want to provide an environment where people are encouraged to come together and talk and not only develop their skills, but develop the skills of everyone in that environment and that community through either kind of talks like the one we have tonight, or through workshops, panel discussions, or just in general conversation. And tied into that is the idea that we want Devbase to become this kind of knowledge base or knowledge hub for all things dev. So to do that, we want to make sure we discuss really a broad range of topics. So whether it's coding best practices or talk about emerging tech, down to more kind of softer skills such as public speaking, and also include things like mental health and diversity in the industry and in workspace. And most importantly for us is that we want Devbase to be accessible to everyone, whether you're a CTO, QA, software engineer, DevOps, down to whether you're a student, part-time coder, or just have a passing interest in tech itself. We want to make sure that everyone feels welcome and encouraged in this community that we're trying to set up. And that's my kind of little spiel there. So now I'll be passing over to Josh and just reiterate, if you do have any questions for Josh during his talk, just like to add them into the chat and we can go through them in the Q&A session at the end. So to you now, Josh. Oh, I think you're on mute, Josh.
Okay, can everyone hear me now?
Yeah.
Cool.
Brilliant.
Okay, so hi everyone, thank you for having me. This is a talk about continuous deployment and GitOps in Kubernetes. I'm a platform engineer at Cloud Technology Solutions in Manchester. We're like a GCP-based consultancy. We specialize in everything Google, including we do things for around G Suite as well as Google Cloud. And I'm on the platform team, so doing mainly Google Cloud platform engineering. Okay, so first, I don't know if everyone knows about GitOps, but I thought I'd mention a sort of a brief introduction into what GitOps is. So GitOps is a sort of methodology where you use Git as your source of truth. So be that in your infrastructure deployments or in your code deployments, more likely it's going to be in your like application development. You're going to have Git as your source of truth. But the way that we use it at CTS is that we use it to sort of facilitate DevOps as a culture, because it allows you to deploy your infrastructure in a similar way than that you would deploy your application code, as you would expect application code to be deployed, where you make a change to your Git and then you have a tool that will make your environment look like what you've got in Git. So this gives you quite a few key advantages. The first one is that all your changes are auditable. So you can base every single change that happens to your environment to a commit that has happened in your Git history, which allows you to not only see who did it, blameless culture I know, but you can see who did what, and you can make sure you know exactly what change caused that thing to happen, and then that allows you to fix things faster. And then on top of that, you've got the same sort of advantage that IAC provides, in that if your entire environment goes down, you know that the exact code that gets the exact environment that you had previously is right there in your Git history as the last commit that was made. So all you have to do is deploy that commit. So a tool that allows us to do that we use at CTS is Argo CD. It's open source, which is top of the list. It's declarative, so like your Terraform or Kubernetes manifests, it can all be written down in manifests, which then mean that it can be put into Git, which mean it can again facilitate Git as a source of truth for even deploying itself. Another tool we use is Google Cloud's Cloud Build as a pipeline for our deploying applications for customers. So what we'll have is we'll have some code that is updated using a Git commit or a Git PR or something. We'll have that being watched by Cloud Build, and then Cloud Build is triggered when something happens, which causes it to build code in whatever way that you need. But in these Kubernetes projects, it will build a Docker image, then it'll push that image to a container registry. Again, in Google Cloud, that's Google Container Registry. Then our pipeline clones a repo of all the manifests that we have, updates those manifests to use the latest image that we've just built, and then push those manifests back to Git so that Argo CD can take over and deploy those manifests to the cluster. I'm going to do a demo at the end. I forgot to mention, I will be doing a demo on all of this. This is sort of just to go over the tools that I'm going to be showing you when I do the demo. Another thing that we use quite heavily is called Customize. It's actually built into kubectl now. And it allows you to customize your Kubernetes manifest without templating. So a lot of people use Helm, which is more of a templating engine. And this moves away from templating, but still allows you to customize your manifest between environments. So you can do things like generating config maps, transforming resource names, and updating image tags and names, which is the last one being the key part of this CICD pipeline. So I'll go into a quick demo. So first things first, I'll just go over some of the things that I was just talking about. So this is your Google Cloud Platform console, in case people aren't familiar with that. And this is the cloud build section. So this is where you define those triggers and the pipelines. So here we've got it pointing at my GitHub repository, which contains my application code, which is just some terrible HTML and a Docker file. And then we have two triggers, one for each environment. So if I look at the dev one, so what happens is it's looking at the development branch or develop branch, and it's watching for any pushes to that branch. And that will cause it to trigger. And when it triggers, it's going to do the steps that are outlined in this YAML. So as I said, it's going to build the Docker. It's going to, this step is important. It's decrypting an SSH key, which allows us to give the cloud build account permissions to pull and push to our manifest repo. So then we take that key that we've decrypted, we make sure the permissions are right on it so it can be allowed to be used. And then we clone our manifest repo. And then we use Customize to set the image to the image that has just been built. So you notice that this image here is the same as this image that was being built and tagged. And then once that image has been set, we then push that to Git using this long bash script. And then this images section tells the cloud build steps that once all these steps are done, push this image into our repository. And the only difference between this and the previous one is the environment that is being changed in the manifests and the branch that it is watching. So I can go to the prod one. You see this one's watching the master branch and it's changing the production customization. It's changing the production image. So next I will show the Argo CD front page. So this is what Argo CD looks like when you've got it all deployed. And these tiles are called applications, which are a custom resource definition in Kubernetes. And so that just means that you can write YAML, which defines exactly what this thing looks like, and you can deploy it to Kubernetes, and Kubernetes will make it work, basically. So this tile, this Argo CD tile, is the main tile, and this is where Argo CD watches its own manifests and deploys those to the cluster. And it also watches all these other applications and makes sure that they are in sync with the cluster. So here we have some of these. I've only got quite a simple setup here. I've got a management cluster which has Argo CD deployed to it, and you can see that this the applications that are deployed to the management cluster are the ones without the suffix on the end. So we've got Argo CD and we've got a KMS secret operator, which I'll talk about a little bit more in a second. And then we've got a dev cluster where Argo CD is deploying a demo application, and it's also deploying the KMS secret operator. And we've got a prod cluster where it's deploying the exact same thing. But between these applications, we can change the image that we want to deploy. We can change the names of things. We can change the config that we have defined for those apps. And then we can manage them from one central cluster. So the KMS secret operator is something that we use at CTS to manage secrets and allow them to be put into your source control without being compromised, because secrets by default in Kubernetes are only encoded, they're not encrypted. Whereas this allows us to encrypt our secrets and then decrypt them on the fly on the cluster. So this is the application that we have, and you can see that it's currently broken. We have spelling errors all over the place, and this image isn't very nice. So this is our dev site, and this is the prod site, and they're both broken. So what we need to do is we need to update our code and then push that and build a new image and then push that through the environments to get it to prod. So what we'll do is we'll go to our terrible code, and I've got this incorrect HTML. I've got a corrected version of it here that I made earlier. So what we'll do is we'll just rename that one. Wait, no, I'm going to rename this one first. Okay. And we're on the develop branch. You can see, can everyone see my ID? Okay. It's all zoomed in enough. And, okay.
Yeah, that was good.
Thank you. So we've got this change to our HTML, the one that works. We've deleted the right one and we've added the wrong one. So add that and we'll say fix HTML. Then we'll push that to the develop branch. And what we should see here, fingers crossed, is that once this is all pushed, we can go to our cloud build and to our history page, which shows us, it streams the builds. And you can see that the dev trigger has built, it was triggered 2 seconds ago and it's already building. So you can see that that's super quick, that it watches the repo and updates. And so it's going through all the steps. This is the logs for all the steps, and you can dive in and look at the logs for each step and figure out where you are. Or you can just stream the logs as it goes on. So this takes like a minute or so. So what it's doing is we've got the build step, which downloads it uses the Docker file that I've got in my code, which is here. It's Nginx unprivileged image, and it's just uploading the assets to it. That's all it is. Super simple. So it builds that really quick, and then it decrypts our SSH key, changes the permissions on it, clones into the manifest repo, and then it does the customize edit step, where it pulls down we have this image that does the customized stuff for us. And then it pushes the new image tag to Git. And then this step is pushing the actual Docker image into the registry. So now that's all done. And we can go to Argo CD. So what we would normally have is you can have Argo CD set up with a webhook as well, so that it will also watch the manifest repo. When the manifest repo gets updated, it will send the webhook to Argo CD, and Argo CD will automatically update. If you don't have that, Argo CD polls for differences every, I think, 3 minutes. But what we can also do is we can go into our application, the dev application, and we can refresh. And that will sync, it will see the new tag, new commit. It will sync that, and you can see it created a new pod and then deleted the old pod. So rolled out a new image, and you can see the image tag there should match up with the commit tag, which we can see here. And then we can go to our site and refresh it, and everything is spelt right. And our picture has changed, and we're now Kubernetes masters. Yay. So the next step would be in a normal workflow would be to take that code that we know works and merge it with master. So let's do that. Create a quick pull request. Oh no, there's conflicts. Let's do that here. Oh, no. I think this is going to be right. Nope, let's not call it that. So we want the HTML to be the incoming change of that one. Sorry about that, everyone. That did not happen in the run through. So now we've pushed to master. So we should see, yep, the prod trigger has built. And again, this is going to take like 1 minute and 38 seconds, and I probably should have prepared some kind of banter to have in the meantime. So I will try and think of something. What I can do is show some Kubernetes manifests for this. So we have, this is our demo app. So what we've got is we've got a module where we have sort of things that will be the same no matter what cluster you're on. So we have the deployment.yaml, which is just a really, really simple deployment, just deploying the Nginx stuff. And then we've got a namespace for it to sit in, which is called demo. We've got a service to deploy it, which is just a load balancer service. And then we also use Kustomize to gather all these resources and also generate a config map from our default.conf Docker config. So what this will look like is if we go to our Kubernetes repo and then we do Kustomize build on the modules demo app, we can see that we've got Yep, we've got a config map now. Instead of just being called nginx conf, we've got nginx conf 75 blah, blah, blah. And then we can go up here and it's created using that file that we passed in. It's created a config map with that exact same name. So what it's done is actually it's created this config map with a suffix and then updated our deployment. It's seen that we're using this config map and updated that to use this config map. And what that gives us is when we update a config map, when we update this file and push that, it will update the config map. And normally with Kubernetes, you would have to restart the pod manually to get that config to refresh. But what this allows is it will change this hash at the end and then change it on the deployment as well. So the deployment will automatically re-roll all of its pods. And that's like a super cool, sort of hacky, cool thing that they've done there. But you'll notice that here that what we've got is in our deployment, we've got an image that's just called Argo CD demo. It's not an image that exists because we then go to dev and we have our customization.yaml, which gets all the resources from that module, which is the shared resources that happen. And then it takes this section, which is called images, and it looks for an image called Argo CD demo, and then it updates that with the actual image name and the actual tag. So you see that commit is the commit that we've just updated it with Cloud Build, and you can see in the commit history it's by Cloud Build updated the Argo image. So now this should have done that, and hopefully Argo CD will have done it all itself. See, it has not. I think it's about 3 minutes that it takes. Yeah, so we refresh that and it pulls, creates the new image, creates the new pod and deletes the old one. And we should be able to refresh our prod page, and prod is now fixed. So that's a super quick run through of how we do CICD for applications in Kubernetes using GitOps tools and Cloud Build in GCP. And there's probably like tons of questions on that, but let's go back to the presentation. Does anyone have any questions? And also, I've been told to mention that CTS is hiring, and you can come and join our platform engineering team and learn about all these crazy things that we do with Kubernetes manifests.
Cool. I thought that was really interesting. Thank you, Josh.
No problem.
Just looking through the chat, we've got a couple of questions.
Mm-hmm.
So a question from Michael. Is the SSH key for access to the manifest repo attached for a Git user, a bit like a machine user?
Yes, so with this example, I've attached it to my user account because what this does as well is Kustomize can allow you to do something where you take manifests from a GitHub repo. So this SSH key needs access to two repos. It needs access to our manifest repo, and it also needs access to our KMS secret operator repo, which contains all the manifests to deploy this, this application. And if we didn't do it this way, it would mean that every time we use this application, we'd have to write out like all the deployment files and everything. And what this allows us to do is have a set of manifests that are versioned and can be used for every project really easily. And we do the same thing with Argo CD as well. So this SSH key needs access to like 3 different repos. And so in GitHub, the way to do that would be using a machine account. But for this demo, I've just attached it to my account.
Cool, thank you. Another question by Josh. Have you ever looked at or considered using GitHub Actions We've been experimenting with it lately as opposed to using AWS's code pipeline like we have in the past.
Yes, so we've only been on GitHub as an organization for like a few weeks, really. Like we've been moving from GitLab in the past couple of months. So we haven't really looked into the things that we can do in terms of like GitHub Actions yet. We did look at it with GitLab, the GitLab CI stuff. And the great thing about Cloud Build is with some of these things like doing this decryption stage, which uses Cloud KMS, which is another GCP service, and with using Google Cloud's repository and everything like that, we already have the permissions baked in because this Cloud Build uses a service account which has permissions to do things. So for our needs, especially when we have customers in all different places, so some in Bitbucket, some in GitLab, some in GitHub, it really works to just have one central place where we can do our pipelines.
Cool. You're not even breaking a sweat with these questions. Another question from James. He says, thanks for the talk, Josh. Keen to understand the reasons behind going for Customize over Helm.
Okay, so at the time when we were developing our plans we were sort of developing our whole methodology for Kubernetes, Helm wasn't at the stage it is now. So obviously Helm 3 has been released now, but at the time it was still Helm 2 and it was still Helm and Tiller. And we weren't so we'd read some articles and read around the relationship with Helm and Tiller, and we weren't particularly happy with the security implications of that, and we'd read some horror stories about it. And also we had a requirement for I think it was sort of a style choice, really. I think it was really the way that we wanted to see our manifests written out there. But it's mainly the first thing I said.
Yeah, cool. Another one from Renato. Sorry, there's been another one. Sorry if this is out of context, but do you have any technique to run services in build/test time on Cloud Build?
Sorry, could you repeat that?
Yeah, sorry. Do you have any techniques when running services in building and test time when on Cloud Build? So have you got any tips and tricks?
Not really. I think one thing I do like is with Cloud Build is the fact that you've got all these Cloud Build images that you can use. So that's really cool. Google has managed Cloud Builder images. So for example, this Docker image that we use, it's specifically built to be used as a Cloud Builder. And there's a gcloud one for our gcloud options. And there's also a Git one for doing Git stuff. It's like it's almost like it was built for doing pipelines. So that's one thing. And another thing is there's quite a lot of different ways that you can deploy things. So what we do is we use Terraform to define our build triggers. And in some cases, we've used Terraform. Like in this case, we've used Terraform to define the steps declaratively in Terraform. But you can also define a Cloud Build configuration file, which we've done as well in the past, which is basically, it looks exactly like this YAML, but you can have that sit with your application code. And when the trigger is built, did I do that? When the trigger is built, it will look at this Cloud Build configuration file and get all the steps out for you. And another one is you can just have a Docker file sat there, and it'll just assume that you want to just build that Docker image and push it. If that's all you want to do is build a Docker image and push it, you can just have a Docker file, point to a repo, and when that Docker file or any file in that repo is updated, it'll just rebuild and push the image. So yeah, there are quite a few ways to deploy Cloud Build, and you just choose the one that's easiest and best for you.
Nice. Another question from James. For initial provisioning or bootstrapping, such as the creation of the GKE cluster, do you still utilize infrastructure as code tooling?
Yes, so we use a combination of Terraform and TerraGrunt in a similar way to our Kubernetes modules. So we had this Kubernetes methodology, which is modules and then a sort of a layer above modules, which just customizes the code. So you sort of keep it dry, so you don't have to write it over and over again. So what we've done is we've written some modules, and we write these modules for the project and what the project needs. And then we have this layer above that just customizes those and applies some config to them using a tool called TerraGrunt, which is just a wrapper for Terraform and does some extra things. But we do still use Terraform to deploy our GKE clusters. And we use the Google modules for as much as possible. So there's a Terraform Google Kubernetes Engine module that we try and utilize as much as possible. And it allows you to really get some really best practice clusters out of it with quite little work. I think that answers the question. Does that answer the question?
I feel like it does.
Yeah.
And then the last one, it's quite a big one. This is from James. Appreciate this is a bit of a curveball compared to the talk, but I think it's an interesting one. At CTS, how do you manage the interaction between cloud resources, so like you manage databases and Kubernetes? For example, for GCP, pushing things like service account keys created into pods so they can auth with a service like PubSub, or putting connection strings for databases into kube secrets. Is there a good way to manage this?
So as I mentioned, we've got this, in the past, we've used this thing called Bitnami sealed secrets to make sure all of our secrets are encrypted fully before we push them to our Git repositories, which made us feel safer in the knowledge that our service account keys weren't being accessed, even if someone got access to our Git repository. And then we've also been using a tool called Vault by HashiCorp, which I'm sure many people are aware of, to manage secrets. And we also have this tool that I've used called KMS Secret Operator, which uses Google's Cloud KMS as a backend for encrypting the secrets. So that all gives us the knowledge that our secrets are as secure as they can be. So that's for things like your passwords for your databases, and if you feel like you need that extra level of security for your instance connection strings, that's a way we can do that. But we also use this thing called workload identity, which is built into GCP now, which allows you to associate a Google service account in GCP with a Kubernetes service account on your cluster. And it's really simple. All it takes is one IAM binding to connect those two things. And that allows you to, all you have to do is go to your, I'm not sure if I've got it in this example. Oh, I do have it in this example, in fact. So all we have to do is go to management, nope, not that one, management. And you patch the service account that you want. So in this case, I have a service account called KMS Secret Operator Manager. I patch it with the GCP service account that I want it to use. And then, so this service account in GCP is called KMS Secret Operator. It's in my management project, and it has access to all my KMS resources. So I tag that service account with that GCP service account, and then I tell my deployment, if I just build this out. I tell my deployment to use, where is it going? Service account name, KMS Secret Operator Manager. So that's that service account that I mentioned here. And this deployment now runs with the permissions of that GCP service account, and has full access without needing any service account key at all. And I would fully recommend using it. It's now GA in GCP, which means it's fully backed, and it's saves you a lot of worrying with your service account keys, because you just don't need them anymore, and you don't need to worry about rotating service account keys or anything like that. It's all just covered for you.
Nice. I think that's end of the questions on the chat. I just have a quick one, and it's quite high level. Is there any reason you choose Google as your cloud service provider? Just out of interest.
Well, Google's actually the only service provider that I really ever known. I came from uni straight into CTS, and CTS we're using GCP when I started. But CTS, in a more high level overview, CTS used GCP because they were already selling G Suite and were already a Google Cloud partner, and then branched out into their cloud platform naturally. And I think it gives like an interesting level of expertise when you only need to worry about one cloud platform, because I struggle so much trying to keep up with just one cloud platform. I don't know how you do it when you're covering all three of the major ones.
Oh yeah, cool. Makes sense to me. I'll do a couple, this last question, and then we might have to move on, unless we're okay with time, Molly. But I've got a question. Do you want to show the binding from the other side in the Terraform?
Yeah, sure.
That might not be a question, that might be more of a hint.
So we've got my Google Service account, KMS Secrets, it's called KMS Operator. And then we've got an IAM member which gives it the role that it needs to encrypt and decrypt the secrets. And then we have the bind-in for workload identity, which binds this this special service account, which is created when you create a Google cluster. Let me quickly jump to the. So when I create the GKE cluster, there's this thing called an identity namespace, which is the project ID.service.id.goog. And then when you generate this special service account, you use the identity namespace, and then in here you've got the namespace / the service account name of the Kubernetes service account, and that binds this special Kubernetes service account language to the Google service account with this IAM role, which allows it to use the workload identity. And that's all you need. So you just need this binding is key, and then that service account patch, which just adds the annotation to the service account, which just reiterates that this service account uses this KMS operator service account in GCP.
Cool. I think Ali's happy now.
Yeah, Ali was definitely just hitting at me to show that.
Cool. I'll round off the questions there. If I'm all right, Josh, to steal the show.
Yeah, I'll stop sharing.
And I'll share my screen. No, that's come out of that. Cool, just double check everyone can see my screen.
Yep.
Don't worry, we've done the Q&A, so that's brill. Cool, I think that was quite a good discussion. I think that's the biggest discussion I've ever been in a meetup. So yeah, thank you everyone for attending. I hope you all found it as useful as I did. I've learned quite a lot, to be honest. So we'd like to hear your feedback and thoughts on our very first event. So that'd be great. Do this via email or, you know, find us on LinkedIn, anything. We'd appreciate that. But before I close off, just want to let you know about our other events that we hold as part of the Masters of AI. So we've got our ensemble, which is more a data science focus. And the next one is week commencing the 27th of July. It's going to be around ethics in AI. Then we follow by Masters of AI, which is more our business event track. And it's a great way for AI business experts to talk about their customer case studies. And that's going to be on the 30th of July. And then lastly, we have Innovate. And this is great for like just bringing general AI awareness to companies. Yeah, so if you're interested in any of those, feel free to hit us up and have a great evening. It's been really good seeing you all.